Welcome to the Nokia Optical Networking Learning Essentials video series from the Nokia Optical Network Certification Program, an end-to-end learning program supporting Nokia 1830 PSS, VWM, and NFMT-based networks. Today, we'll look at traffic survivability through GMPLS protection and restoration combined, or PRC. This video has been created based on the Nokia GMPLS Controlled Optical Networks course. In this video, I will explain the PRC mechanism implemented at L1, describe the multi-regional network model, or MRN, and describe how to configure the restoration through NFMT. We will configure a GMPLS L1 restorable PRC service, which provides a combination of fast protection with robust restoration. The service is protected by the Subnetwork Connection Protection, or SNCP, with a guaranteed recovery time of less than 50 milliseconds. Moreover, it provides multiple failure recovery iterations because the restoration process is repeated for successive failures if suitable resources are available in the network. In this example, we can see a sequence of steps happening in a typical PRC-protected traffic flow. Note the active main route represented by a straight green line, where data traffic is routed initially. Note also the standby spare route depicted with a dotted green line. Here, we can see the consequence of a link failure between nodes 1 and 4. As a result, the service quickly switches to the spare route thanks to the SNCP protection mechanism. Immediately after this switch, the service is not protected anymore by SNCP, and thus is vulnerable in case another network failure happens, as would happen in a typical simple 1+1 protection schema. However, this is not the case for PRC. The original main route can be restored thanks to GMPLS, bypassing the network failure. The actual traffic is routed over the spare route, now represented with a straight green line, and the new main route, represented with a dotted green line, is now acting as a standby protection route. The same sequence can be repeated multiple times. For instance, after a second failure happens between nodes 3 and 6, the traffic is switched within 50 milliseconds thanks to SNCP, and the failed leg is restored thanks to GMPLS. We will apply this concept to an MRN, which is composed of OTN nodes with control plane enabled in both photonic and electrical layers, or L0 and L1. A single control plane instance coordinates the two layers. To do that, the L1 routing over the L0 infrastructure is based on tunnels, logical associations between two termination points of the same network layer. This is the network we're about to use to create a service over the 20AN80 client boards equipped in the two termination nodes. Let's move to the NFMT GUI for the next steps. First, we must verify that the network is implemented and ready to support traffic. Let's go to the Network Protection Architecture, or NPA list, by using the Operate NPAs menu. Select Item, Lab 5, NPA, which is the NPA this network belongs to. Check that all ASIN links have been unlocked by selecting the NPA ASIN Links tab. In this network setup, we have 4 ASIN uplinks routed by the MRN network. Since they are MRN unterminated tunnels, they have both L0 and L1 capabilities. Now that we're sure that the network commission has been done properly, we can provision a 10 GBE PRC service. To do that, let's open the Service Creation Wizard by clicking on Deploy, New Service, Infrastructure Connection menu. Then, under the Best Practices template, locate the 10G Ethernet item, right-click and select Deploy. A new window will appear. Do the following on the wizard. Set the rate equal to 10 GBE and container to ODU2E, as this is the rate available for the selected I/O client card. Set protection type to Protected. Select the termination node's endports. Provide a meaningful label in Connection Name field. Tick the ASIN Routed checkbox and verify the ASIN restoration type is SBR. Verify that the ASIN parameters and priorities are suitable for the service being created and enable the Wait for Server Restoration option. This implies the network will wait for a photonic switch before attempting an electrical switch. Set the routing constraints for the main and spare legs as requested. Finally, deploy the service. Now that the service has been created, we can verify that it has been added to the NPA and check the nominal and current routes. To do that, in the ASIN SNCs tab within the NPA menu, left-click the service container to see the details. A new window will open, and from there, go to the Routes tab. In the panel on the left, we can see the nominal route, which is the route configured initially at setup time. In the panel on the right, we can see the current route, which is the actual route taken by the trail. In case no failures occurred, nominal and current routes are the same. Since the service is protected and not only restorable, we can globally see 4 routes, 2 for the main and 2 for the spare leg. So to recap, we created a 10 GBE PRC service over an MRN network. PRC is the restoration mechanism with the best performances as it combines the advantages of fast SNCP protection together with the SBR restoration. On the graph, we can see the higher performances of PRC with respect to the other available options. Finally, to deploy such a protected and restorable service via NFMT, some network resources should be assigned in advance to the related NPA. This is part of network commissioning phase. Then, by using a specific template and by flagging all relevant ASIN-related checkboxes, the new service can be routed and managed by the control plane instances available on all nodes. Thanks for watching, and look for more videos in our Optical Networking Learning Essentials series. Whether your goal is to enhance your optical networking skills or demonstrate your expertise through one of our 4 industry-recognized certifications, the Optical Network Certification Program is here to get you, your career, and your organization on the right path. Our program features 9 instructor-led courses developed by our team of subject matter experts using industry best practices, use case-driven examples, and hands-on labs. Learn more and get started today by visiting our website. Thank you.